Hello 8th graders, today we are going to start on ELR 6.2. 6.2 is all about graphing displacement versus time, whereas before we were just calculating it to find velocity, and we also did speed at the same time. The whole point of this is to be able to make a picture that represents some object's trip, and that picture is a graph. Now we can just look at the graph, and the number one mistake that I sometimes see is people think that this line on the graph is like a map. And this is what the object did. It took a little right turn right here, and then it took a little left turn, and that is not it at all. This graph is showing how quickly something is going and whether it is moving towards or away from us. And that's what we're going to work on for this lesson. The objective looks like this. Your job for this lesson is to be able to create and interpret one of these graphs. The place where we have to start is with a data table. So every good graph has data that makes it, and this is no exception. Let's say that we have a really simple situation where we've got some object, this robot, that's moving one space away about every second as time goes on. Well, if we were to make a graph of this, we would plot our time 0, and he started on the first box, and every second after that, he moved one more box, and he just kept going like that. If we were to graph this information, we would get a nice straight line on a graph just like the one on your screen. Now, the thing about these graphs is that since we are doing displacement and we're doing time, I know you've done slope before in your math classes. If slope is the rise over run, and the rise part is the displacement, and the run part is time, well, displacement over time, that's what velocity is. We've calculated velocity before. So the big key takeaway for this lesson is that the slope tells us how fast this object is moving, all the time. In this class, we're going to deal with 4 different types of graphs, and your job is to be able to identify them on site. So we're going to start with the first one, and this is what's going on your paper. You're going to sketch a little sketch of the graph. The first one is constant positive velocity, and that's the one that we already looked at. Some object is moving along in a positive direction at a constant rate. When we do that, we're just going to get a nice straight line. The steeper the slope, the faster it's moving. But you're always going to get a straight line that slopes up and away. And that's because the displacement is getting greater at a constant rate. The next one is constant negative velocity. Suppose you have the same robot, but this time it's coming towards you. Well, because the displacement is shrinking, it's getting less and less every second, this is going to have a negative velocity. This is when we're going to see the exact same type of graph, except just sloping down. Again, how steep this graph is tells you how quickly the object is moving towards you, or in a negative direction. The third one's pretty simple, 0 velocity. The object's not moving. It's just hanging out in one spot. For this one, you're always going to see a straight line. As time moves on, the displacement doesn't go up or down, we just get a flat line. Now this flat line can be at any spot. Maybe he was standing on the 9 marker or some other spot. Well, then you're just going to see a flat spot on the graph wherever the object was standing, but flat means 0, no movement. The last one we're going to deal with is some acceleration. This is where the object starts off slowly and then starts picking up velocity as it moves. This one is not going to be a straight line, because if you think about how velocity makes a straight line, if acceleration is when you're going faster and faster, you're making your velocity bigger, that amount of steepness is going to keep changing. And so what we get is a curve. Every time you see a curve on one of these, you're going to know that that's acceleration. I'm even going to throw one with deceleration at you, where something is slowing down. But the thing you got to know about is curving lines mean changing velocities. So on your paper, there's a spot where it says quick write. What does the slope of the line tell you about the motion, and what does a steeper slope mean? We're going to do this part a lot more later, but for now, to help you to answer that question, take a look at these 2 lines on my screen. We've got the blue and we've got the red. The blue one has a much steeper slope, so we already know that that one is going much faster, but I want you to be able to prove it to yourself with actual numbers. So if velocity is the displacement divided by time, notice that both of these lines start at 0 for displacement on the left side. Well, the blue one manages to go up to 10 in just 2 seconds, but the red one only goes up to 4 in just 2 seconds. We can actually calculate those things by doing rise over run, that's displacement over time, and we can find out that the blue line, B, managed to go 5 meters per second, whereas the red one, A, only went 2 meters per second. So on your paper, you need to summarize to yourself, what does the slope tell us about the motion of the object? Pause the video now. The next step of this is to get a little practice with an actual object in motion. So I have this PhET simulator. Here's what it looks like. The way this works is when I grab the little person and move him around, he slides back and forth as time moves on. The computer's keeping track of his displacement. Your job is going to be to predict what the graph is going to look like once it gets revealed. So for example, when I just moved him around just now, this is what his graph made. So your job is going to be to predict what is that graph going to look like when I'm done. So for the first one, here's the description of what I'm going to have the moving man do as he makes his graph. Add this description to the description box on the top where it says number 1. He's going to move at a constant speed toward his house, stop to tie his shoe, and then he's going to walk back to where he started at a constant speed. Pause this video and add the description and sketch out what you think that graph is going to look like before starting the video again. If you're still watching, you are ready to see how this plays out. So the running man is going to move at a constant rate towards his house. He's going to stop to tie his shoe and then turn around and walk back to where he started, also at a constant rate. When we go over and we check our graph, here's what you should have. You should have a nice steady increasing slope to start with, then a flat spot where he tied his shoe, and then a nice steady slope going back down to 0 because that's where he started. For the second one, we're going to make things just a little bit more complicated. This time, he's going to be standing at his starting place for a few seconds, then he's going to see a spider and run towards his house, so we're going to have really fast. Then, the third part, he's going to stop to catch his breath for a few seconds before slowly walking back to see if the spider is still there. So for this one, make sure you're showing the differences in the velocities for this graph. Pause this video if you need to add the description to your paper. So for this one, we're ready to check to see how your graph looks. The running man stands still for just a few seconds. Then he sees a spider and runs really fast towards his house. Then he stops to catch his breath for a few seconds before very slowly walking back to see if the spider is still there. And we'll have him stop right there. Now we need to check to see what our graph looks like. We should have a nice flat spot right at 0 where he was standing still, then a super steep line where he went really fast, then another flat spot where he was over by his house. These two flat spots need to be separate from each other. Then we have a nice shallow line that goes back towards where he started, sloping down because he was moving in the negative direction that time. For the third one and last one, this time the man is walking at a constant rate towards the tree while starting at his house. He's going to turn around, and immediately when he gets to the 0 mark, then he's going to stop a few steps away from the house again. Pause this video if you need to add the description and make your sketch. If you're still watching, you're ready to check to see your graph. This time the running man is starting at his house. He's going to walk towards the tree, turn around when he gets to the 0 mark, and then stop a few steps away from his house again. So he's walking towards the tree. Once he gets to the 0 mark, he's going to turn around and start walking towards his house again. And all the while, I tried to make that as constant as I could. You're now ready to check your graph. Here's what we should have. Because this time he started away from the 0 mark, he was up at his house, we have to start our graph up somewhere here. And it slopes down because his displacement was decreasing as he went towards 0. Then when we hit 0, we turned around and came right back up. So you should basically have a better than mine, but a nice steady V as it goes down and back up. Number 4 on your paper is where your turn is to make the story. So this time I'm giving you the graph. Your job is to write down what the man may have been doing. So there should be 4 parts to your story that go with each of these 4 parts on the graph. Pause the video and write your story now. If you're still watching, you're ready to basically check your answer. So whatever you put for A, you should have some sort of slow positive velocity. The man's moving away from the 0 mark in the positive direction. For B, you stopped for some reason. Then for C, there should be fast positive velocity. He went really fast, we know that because it's a steep slope. And then for D, negative velocity that's also relatively fast, so returning back to where he started. The last thing that you need to do for this lesson is go into Google Classroom and open the Graphing Velocity Practice Google Sheet. On tab 1 is where you're going to start. Here's what it looks like. Down at the bottom of the sheet, you'll notice that there are two tabs. The first one says Practice Graphs, and the other one says Make a Story. We're going to be working on the Practice Graphs one to begin. So let me zoom in just a little bit. As long as you're following along from top to bottom, you should be all set to go. So in the first part, your job is to use the data table to make a graph and then answer questions 1 and 2. If you're not sure how to make a graph, it's been a while, you can click on the link right here and it'll remind you how to make a graph in Google Sheets. So you'll make a graph, plop it down over here, then you'll be ready to answer the questions below. The next part is where you're going to be dealing with an object at rest. You're going to do the exact same thing, make a graph, and then answer the questions. You can also check your answers by clicking on the links. I forgot to say that. There are links to be able to check your answers also. Then you're going to get to part 3, same idea, check your answers. The very last thing that you need to do is the Make a Story tab. Over on the Make a Story tab, this is where you're going to do the reverse. You're going to make up a story and type it into this yellow box, kind of like what we did with the Running Man. You're going to have to make your story have these 4 parts. I don't care if they go in this order, but all 4 parts have to be in your story. So you're going to have slow velocity, fast velocity in the positive direction, 0, and negative. If you want to add more parts than that, that's fine too, but it's got to have at least those 4 parts. Now, here's the tricky bit. You need to add in the displacements, the actual numbers, so that that graph gets made. So I would recommend that you have the person start at a displacement of 0, just like when the Running Man was standing on the 0 mark. And then you have to change the displacement in all of these boxes so that the graph that gets generated matches your story. If you put in a bunch of numbers, highlight everything, and make your graph, you can change the numbers here and your graph will reflect it as you go if you need to adjust it and see how it's changing your graph as you work. Down at the bottom, the last step is to calculate your object's overall velocity. We're going to handle that in our next class. Your job right now is just to make the graph.